everyone, my name's Erica Webb and I have done my lecture presentation on meat fermentation. And this is a continuation of the first lecture, so this would be lecture 2. We ended the last lecture with a talk about starter cultures and how lactic acid bacteria along with Staphylococcus were two of the main microbes that were involved with fermentation, but there's a lot of other microbes that are involved as well. Yeast and molds are a common part of most of your meat products. They're already naturally there. So one of the goals of fermentation is to allow both yeast and molds, along with certain fungus, to metabolize and ferment, but we don't want those compounds present at the end of our fermentation process. So the high temperatures that occur during fermentation are going to allow those yeast and molds to grow, but at the end of fermentation, typically the levels decrease. Enterococci is another another microbe that's naturally occurring, and it grows throughout the whole fermentation process and remains relatively constant until the end. It's a poor acidifier, so it does grow better in a higher pH. It gives it a better environment for growth, and it does have a high salt tolerance. Some strains of Enterococci Enterococci are pathogenic, depending on the genetic makeup of it, but generally it poses a really low risk, and according to the FDA, it is labeled as safe, although there is some controversy. So here's a list of certain bacteria and yeasts and molds that are common for fermentation. It shows the effect on food and what end product is generally given off, along with what sensory attributes play a role due to the end products of these compounds or microbes. So with all good microbes, we have bad microbes. There is quite a few bacteria out there that cause spoilage in our food. They are present in small quantities naturally, and they cause the food to deteriorate and spoil over time. The rate of growth depends on the product type, and they don't always get killed off during fermentation, although it would be nice if they did. Then we probably wouldn't have as much food spoiling in our fridges. But Pseudomonas and Enterobacteria are generally two of the most common spoilage bacteria. They're not pathogenic, but I probably wouldn't want to eat them. And they're higher in products that don't dry out as well, which is really important why we need to go through a drying process, which will be discussed later in this lecture. We also have pathogenic bacteria, and those are bacteria that cause disease. Sometimes they're present in unfermented products, but should absolutely not be detected in finished products. Staphylococcus aureus, Listeria monocytogenes, and Salmonella are some of the common ones. I'm sure you've heard of most of those, and ingestion of any of those will make you really, really sick. The good news is the process of fermentation generally prevents the growth of these types of bacteria, which leads to just an overall safer product with a longer shelf life. So due to the ideal environment needed for the growth of these microbes, certain microbes are added to our mixture to prevent other microbes from growing, and that's just considered an antagonistic effect. And it's another reason why we add salt concentrations to our mixture, and it's to prevent certain microbes that don't like salty environments, to prevent them from growing, but allowing other bacteria to be able to grow and ferment. So lactic acid bacteria, Staphylococci, cocci, and micrococci are not sensitive to salt concentrations, pH fluctuations, or high temperatures, which makes them really good competitors against other bacteria. Oops. So once we have our meat mixture and everything fermented, if we look a little farther out, we're looking at the casing that our meat product is being held in. And the purpose of these casings is just to not only form the product, but help protect the product from outside microbes and outside environmental substances. Some casings, especially your natural ones, are going to add flavor to the meat. That's apart from the flavors that are coming from the actual fermentation processes. And the characteristics of a good casing, we want a strong casing to be able to hold up to the whole, shoving this meat mixture into this casing needs to be able to hold up to that. It needs to be clean. A lot of casings are edible and don't need to be cut off, so we want them to be relatively clean before we ferment them. Diameter is going to be important depending on what we're trying to accomplish with our sausages, and the overall length is going to be profitable for any producer that's making these sausages. There's a few different types of casings. For centuries, natural casings were generally used and were widely accepted, and today they still are used. A lot of the most common casing is going to come from pigs, and they're made from the submucosa of the intestines. Generally, they're hardened through a drying and smoking process, which is a process within itself because we don't want to over dry them because they'll end up breaking and cracking. But if you don't dry them enough, they can cause leakage and just not hold up very well. Natural casings tend to be the most expensive type of casing just because they require a lot of hands-on labor in order to get them to where they need to be cleanliness-wise before we can even put our meat mixture into them. Most of them, if not all of them, don't have to be peeled before eating, so after the whole fermentation process goes on, you can just slice it open and eat it right then and there. Although natural casings are still widely used, we have a couple different options of artificial casings, and these are generally made from things like collagen or cellulose or even plastic, and some of those have to be cut apart or opened up before you can eat the meat mixture, the fermented meat inside. So this table shows a brief description of a couple different types of casings. Like I said, typically you see a lot of casings come from hog intestines, but they do come from sheep and beef intestines as well. And depending on what kind of meat product we're looking at, depends on what type of casing we use. A lot of them are typically just based off diameter, so your smaller breakfast sausages are going to have a casing that comes from lamb intestines. Your Italian sausages and bratwurst are going to be from hog intestines, and then your larger salamis and bolognas are going to be from beef intestines. So fermentation is a really important process and really extensive process, but without a drying period, our fermentation process is not going to be as important. The purpose of the drying period is to slow the action of all the enzymes that we've got going on in there. We also need to remove the moisture that's in these meat mixtures so that molds and bacteria can no longer grow. And during the drying process, we typically see some shrinkage of the meat and a reduction in weight just due to the reduction in the amount of water that is in that product. And it does make it a little bit more profitable for packaging and shipping, just as a side note. Typically, our drying processes are done through a heat application. There's a few different ways of doing it. You can do it through convection, radiation, dielectric, or conduction, and that's either externally or internally. The main goal is to allow the meat to dry from the inside out. Meat is generally perishable at room temperature, so sometimes a lower temperature is needed for the first initial phase of the drying process, and then it's slowly increased from there. So the time of drying is really important depending on the size of the sausage that you're producing. There's generally 3 different periods that a sausage goes through when it goes through drying. Your induction period is the time where the surface temperature increases up to the wet bulb temperature of the room. That's relative to the humidity in the room as well. That's relatively a short period of time, and then the sausage goes into the constant rate period, and this is the longest of the drying periods, and that's where the rate of the evaporation is lower than the rate of the water transport to the surface. So the water that's going to the surface is evaporating, or is moving to the surface a lot quicker than the water on the surface is evaporating. It means that the overall surface is going to remain wet, and it allows for a more constant drying rate. One of the things that we like to avoid is for the outside of the sausage to get too dry before the inside of the sausage can dry. That typically leads to a harder outer surface and makes a harder casing, which actually traps the water in, and we want to avoid that. So during this constant rate period, the water being transported to the surface will eventually start to decline, and most of the volume reduction or the shrinkage will take place during this stage. The falling rate period is our last period of the drying stages, and the remaining water from the center is carried out by diffusion, and the overall product will reach equilibrium in moisture content with the surrounding air, and the term for that is called sorption isotherm. So this is just a really basic graph showing the phases of the drying period. A would be your initial phase, which is relatively short. B to C would be your constant rate period, and overall not a whole lot. It's one of your longer drying periods. And then from C to E is going to be your falling rate, where the remaining of the moisture leaves the product. So like I mentioned earlier, there's a few issues with drying. We don't want the outer surface to dry too fast, because that leads to a hardening of the outer case and prevents the center from drying, which is called case hardening. Certain temperatures also cause a denaturation of proteins, and that can decrease the stability of certain temperatures, so we want to make sure that our temperatures are at an optimum temperature in order to dry properly and slowly. If the product contains a lot of fat, that can also decrease drying rates, because fat has insulating properties and would need a longer drying period. And overall, we're enhancing the product through this drying period by allowing certain biochemical processes to finish up taking place, and also allowing additional flavors and pigmentations to develop. So now that we know a little bit about fermentation, we might want to question how safe these products actually are. We have a lot of different microbes interacting here, and we might begin to question, are these microbes actually safe to be put into our bodies? A lot of manufacturers look at starter cultures and do make sure that they're safe. They do have to be inspected for certain things, making sure that they contain certain bacteria that we want to help promote growth. We want an absence of other bacteria and enzymes such as amino acid decarboxylase. We want non-toxigenic bacteria, and we also want non-antibiotic resistant bacteria as well. We're doing this because we want the bacteria that is in our starter culture to be able to have a high competitiveness against all the other pathogens that could be in our mixture. Salt also adds an insurance policy for us. Not only does it prevent certain microbes to grow, but you're also increasing or decreasing water holding capacity in that product when you have an increase in salt. We do have consumers now wanting a reduction in salt in their diets, so that leads us to question if we can make this product with less sodium. And certain researchers have tried replacing your basic table salt with other forms of salt that may be a better option, but some of these salts have certain inhibitory effects due to their chemical makeup that could affect the growth of certain microbes that are in our starter cultures. Some of these salts that are replacing our basic table salts are potassium chloride, calcium chloride, and manganese chloride. Overall, according to the studies that I've seen, the replacing of salt, the basic table salt, with those salts doesn't really show a huge difference in microbial growth or anything. So the biggest thing about the meat industry is making sure that we're producing a product that the customer needs and wants. And overall, a customer or a consumer is going to look at a piece of meat and look for something that has high sensory standards. They want to see something that not only looks appealing but has a long shelf life, and that something that contains specific nutrients that cover their needs. So it's important to create a product that's pathogen-free, obviously, or we'd probably get shut down by the USDA. But consumers are also demanding products that have less preservatives, fewer additives, and overall minimal processing, and that becomes harder and harder when it comes to fermentation of meats, because we have to add certain things to them in order for them to ferment and in order for them to be pathogen-free. So a term that's become gained increasing attention over the past few years has been biopreservation, and that's just overall enhancing the safety and shelf life of foods by adding natural or controlling the microbial compounds that we put into products. Some microorganisms that are commonly associated with meat have proved to be antagonistic toward pathogenic and spoilage bacteria, and once again, lactic acid bacteria is probably the best candidate to be used in biopreservation just because of their prevalence during storage. So there's a lot of sensory attributes that are related to our meat products, and although they're not directly related to fermentation or the process of fermentation, it's important to discuss because it determines whether or not the consumer will find the product acceptable. It's hard to measure sensory attributes because a lot of it's due to consumer opinion or perception, but there are certain tests that can be done, and a lot of food scientists have discovered a lot of tests that evaluate, I guess, sensory attributes through by turning the data into a numerical relationship that compares human perception against numbers. It's been so far seems to be fairly accurate, and overall producers are concerned with analytical specifications as far as what those numbers or numerical data shows, along with predicting consumer acceptance. So overall, meat can be described in the following ways. We're looking at appearance, so the color, color intensity, is it shiny, is it greasy? The overall odor, does it smell gummy, or is there an off flavor, is it rancid or moldy? Taste, is it sweet or salty or bitter? Flavor and texture are important attributes, and all these attributes are directly related to the kind of microbes that we use during fermentation. So, is fermented products a good source of nutrition? Overall, meats are very energy dense, whether they've been fermented or not, because they're high in proteins and fats. A lot of them are rich in some vitamins and minerals, and cover about 20% of your needed vitamin and mineral intake. However, fermented meats contain a lot of added sugars and salt, which could be of concern for certain diets. In the more industrial or Western countries, we see a lot of overconsumption of meat, and meats, whether they've been processed or not, account for about 11% of the total energy source. Fermented meats in developing countries could be a really good product to continue to promote. A short in food supply often leads to malnutrition, but fermented meats could provide a good protein and energy source, and because of the longer shelf life without refrigeration, could be a good option for them. So just here are a few pictures of basic fermented meat products. The first one on the left just shows some sausages that are hanging up in their casings in a room to be fermented, and will probably be dried there as well. And then the other two pictures are just showing a wide variety of different products, along with looks like a salami or something up at the top that's been cut open and ready to eat. So here's just some additional information if you're a very visual person and want to watch a short YouTube video. If you just want to Google the art of salami making, it'll be the first one that pops up, and it just shows a typical meat mixture, them adding spices and everything, along with putting the meat mixture into a casing and allowing it to dry and ferment. I got most of my information for these two lectures from the Handbook of Fermented Meat and Poultry, so if you're interested in learning any more, there's a whole lot more information that's a lot more, can be a lot more detailed in certain parts of this book. And there's my works cited page that cites this book as well.